So, like she said, I'm Rob Crittenden. I work at Red Hat. I work on identity management stuff. So I did free IPA for 5 or 6 years, and now I'm working on SAML Federation and OpenID Federation. To talk about federation, we have to talk about identity. So as a system administrator, I tended to think of identity as a login ID, and maybe a realm or a domain associated with that. But really, identity goes beyond that because we have work identities, we have hobby identities. You post to blogs, you post to forums, you are a gamer, this is a lot of different things. So just keep that in the back of your mind as we talk about this stuff. And then the software, you like to keep your reputation by using the same ID everywhere so people know the cool things that you've done. So that's another identity that you might have. And that may be separate from your work identity for legal or other reasons. So again, just keep that in the back of your mind. So federated identity is just a way to use the same identity in a lot of different places. And the reason for this, that people like to do it, is it reduces overhead. So you don't have to maintain a whole bunch of passwords. You don't have to deal with people that don't take care of passwords very well. And also, again, so you can more or less, from a software perspective, it's keeping your reputation intact. So when we talk about federation, there's 3 parties involved. I'm going to use the SAML lingo here just to avoid confusion. And I'll tell you when I sort of go off track and start talking about other specific federated names. So we have an identity provider. We have a service provider. In OpenID, that's called a relying party. That's basically the same thing. And we have end users. So an identity provider is that. All it does is provide identity. And hopefully they're really good at it. So I say trusted here a couple times, and many times in my talk. You got to be careful who you want your IDP to be, because they're holding all the keys to your kingdom. And if you don't choose wisely, you could be in trouble. Now, you guys probably use federation now, and maybe you don't even know it. So when you see the login using Facebook, or login using Yahoo, or login using your Twitter, that's federation. It's probably using OpenID Connect. So, that's kind of handy. You don't have to create a new account on some new blog you just wanted to post a comment. And the other thing about an identity provider is it doesn't have to be external. You can own it if you want. And there's pluses and minuses to that. And I'll get into that in a minute. So a service provider is just a fancy way of saying a web server. So the federated identity is all web-based, usually with a browser, but it doesn't have to. So, these web servers, rather than having local authentication, they rely completely and entirely on an identity provider. And again, these can also be inside your control or outside your control. So you may want to delegate to some third party access to your IDP so that your users can authenticate and do the things you want. And then finally, we have users in my great graphic. So I call this guy Joe. So this is what web users look like today, for the most part. So Joe goes to a whole bunch of different sites, and sometimes he uses a different login, and sometimes he doesn't. And here he's using the same password everywhere, which is pretty typical for the average person. So if you went to yesterday's keynote, this hypersecurity guy, he did this even after he ran into a lot of problems. So, and I know that I do this too. So the problem with this is you have multiple passwords. And if you have multiple passwords, you can guarantee that some of them aren't great. And you're probably reusing some of them. Mostly because you create an account somewhere, you go there once, and you're never going to use it again. So you sort of use the same throwaway password used everywhere, and then you find out that you've used it 60 times. I know that happened to me. Now you can use tools on your phone, LastPass. There's ways around the whole thing. But even then, it doesn't change the fact that you have passwords everywhere. And sort of the big critical thing is you're relying on all these different parties to protect your passwords, which, if you follow the news at all, you know that they do a terrible job of it. So one solution is federation. This is not the end-all, be-all of anything, but this is one way to sort of work around it. So for users, you have one account. I have an asterisk here because you probably have, again, this goes back to identity. So you may have work SAML, you may have hobby SAML, you may have hacker SAML, or OpenID. And again, trusted here is underlined because you got to trust the person you're getting your identity from. It's good for web applications because they can completely get out of the whole "I forgot my password" bit. They don't have to manage a user database. I mean, they may still have a database that contains your preferences or interesting bits about you, but not your identity. It may not even know your name. So what distinguishes Federation, again, you're trusting a third party for authentication, which can be scary. That third party could be your IT. So it's not that scary. It's almost always web-based, almost always over SSL, TLS. And there are command line ways to do some of this stuff, but generally it's browser-based. And some works better in JavaScript than others, but there's almost always ways around it. Centralized versus decentralized, what I mean is, so you can either have total control over the service providers you trust and own the IDP, or you can just be Wild West. So for example, if you wanted to allow Facebook people in, you can do that, but you have no control over who the Facebook users are, or what where they're coming from, and so again, that's another choice you can make. I have a couple common protocols. I'm only going to talk about the first two today. Those are the ones that I know most about. I want to make clear, this is not Federation. Being able to pass your password onto a third party does not make it Federation. So you have no control of your credentials in this case. Basically, you're just proxying. So it's important not to be fooled. So SAML 2 is the first protocol I'm going to talk about. It's mature. It was last revised in like 2005. It's XML and SOAP over TLS, HTTPS. SOAP is just a message envelope. And XML is, well, this was created in late 99, so XML was the big rave back then, so that explains that. So SAML is centralized. You need to have an agreement between the service providers and the IDP, and that agreement is an exchange of public keys, so that the IDP knows all the service providers that it has, and the service provider can talk to multiple IDPs, but it also has its keys, because everything in SAML is signed, and it can be encrypted. And SAML is defined by a series they call profiles, and these profiles determine the kinds of things you can do. And the big one that people like is single sign-on. And you can single sign-on using HTTP redirect, or there's a way to do it using POST. And then single logout is another thing that's pretty cool. So it can basically log you out of all your sessions at once. So SAML, most SAML IDPs keep track of every session that you have. And so that's how it can do single logout. So a little animation. Let's walk through how SAML works. So Joe makes a request to the SP on some secret page. The SP doesn't do authentication. So it redirects to the IDP, and the IDP is going to present some sort of form, probably. If you're using Kerberos, this may be just automatic. Or if you're using username and password, then it's going to prompt you with a form. So the IDP is going to do some way of authenticating that you are who you say you are. Going to issue a token. This is an XML document that's signed. It's going to redirect the user back to the SP, and you're going to profit. So let me show you what it looks like, okay? So this SP is simple SAML, and I'm using Epsilon just as the IDP. So if I'm asking it for some secret information, so I go to Joe, I authenticate, and then it sends me back. So you see that I got a lot of information about Joe. He lives in Baltimore. He's got a phone number. Now, let me show you single sign-on. So if I go to a different service provider, secret, and load the page. So it actually, you didn't see it probably, but it actually redirected the IDP, saw that I was already authenticated, and then sent me right back to the SP. So now I'm logged in. So if I choose logout here, it sends me to a nice logout page. If I go back to the first SP I logged into, I'll show you single logout. If I reload this, I'm unauthorized. So single logout. The token is called a SAML assertion, and it contains a bunch of things. There's different kinds of assertions. There's authentication assertions. You can have attributes. You can, SAML can do authorization decisions too. I tend not to get too much in detail in that. And then I mentioned again that they're all signed. Now, something interesting about authentication is that there's a name ID type associated with it. Name ID, I think there's like 7 or 8 different types. So there's Kerberos, there's email, there's Windows login name. There's something called transient. So basically, every single time you log into the IDP, it generates a UUID, and that's the ID it sends back to the service provider. So if you want to hide your name or your login name from the service provider because you only trust them so much maybe that you're just saying that, yeah, I am who I say I am, and that's all you're going to tell them. They'll just get a unique ID that they can use for that session, and you log out and you log back in, you get a new one. There's also a persistent type. And that's another UUID that's generated based on the IDP you're logging into and I think your name, or something that's you can run over and over and get the same value out of. And it's similar. It's just a random set of bits, but the service provider can use that to save profile data on you. But again, they still don't know anything about you other than what the IDP has sent. And so the IDP sends information in the form of attributes, and these can be email address, your mailing address, groups that you're in, who knows? Anything that you want to store in your identity provider, you can send in an assertion. So I want to show you, I know I just showed you Logout. Let me show it in my little animation because you'll see in a second. So again, you go to the first service provider and you issue a Logout request. It's going to redirect that to the IDP, which is going to find all the sessions. Now, logout can happen. There's 2 profiles for logout. There's logout using redirects. So basically, your browser is going to revisit every single SP and issue a logout. And when it's all done, you'll finally get redirected back to the IDP, and the IDP will say, I have no more sessions. Let me log out the initial request, and then you're sent back. Now, that can be problematic because if any one of those logouts fails for some reason, the SP's down, it forgot about you, whatever, the whole thing stops, usually. So it's kind of broken. You can also log out using SOAP. So that's what I'm showing here. So basically, the IDP knows all your sessions. It knows all the service providers. So it contacts them. And so if any one of those fails, it's less problematic. So again, SP2 will process the logout response. It would generate a logout response, send it back to the IDP, and then the IDP sends, you're all done, to the initiator. So why use SAML? This is typically enterprise. This is centralized. You have total control over it. Single sign-on is the primary reason that people like this. But you can think about, so Salesforce.com, they support SAML. So if you want your salespeople to be able to use Salesforce without having to set up a whole set of different identities for them, create a SAML federation, and then your employee logs in locally, and then he can access Salesforce with his local ID. Now, whether, in Salesforce, you can set up whatever identifier with them you want. You can use a persistent ID. You can use your real ID. It doesn't really matter to Salesforce. And they just use it for authentication. I don't even think you need to send any attributes, maybe your name. I'm sorry?
They'll also do just-in-time provisioning. So Salesforce has never seen the user before. The IDP says, hi, this is new user Bob. Salesforce will automatically create a new account for Bob. I used to work on the security team at Salesforce and filed quite a number of bugs against it.
Okay, so just to repeat, so one feature of Federation 2 is, so this is the first time you log into a site, okay? And it knows nothing about you. All it knows is that you're authenticated by some remote party. They have ways to automatically create accounts for you. So he was mentioning that Salesforce does this. When you log into Salesforce for the first time after authenticating, a Salesforce account's created for you to store whatever Salesforce information you needed to keep. And it's also another use case that's often used with SAML is that you want to go to a airline site and book a trip. You authenticate with SAML, and then you can actually transfer that to other SPs because it's single sign-on. So you book your airline, and then you go over to book your hotel, and the same authentication works there too. So this is I just kind of Googled And here's a whole bunch of identity providers. So I've used Shibboleth. Shibboleth is sort of the gold standard of IDPs. Keycloak is one by Red Hat, so I should have put a little asterisk there. So is Ipsilon. That's the one I work on. Simple SAML PHP is a PHP-based IDP and SP. It's pretty slick. OpenSSL, I think, is Oracle. And there's a bunch more. So this is just to give you a taste that there are a whole bunch of people doing this. So as for service providers, again, Shibboleth, Keycloak. Monolith Melon is an Apache-based SP. That's the one I showed here, one of the, and Simple SAML PHP as an SP. And again, OpenSSL. So there's lots of ways to do it. It just depends on what you want to do. So the advantage of something like Monolith Melon is you don't have to install a whole bunch of stuff. All you have to do is install the Apache module, exchange the keys as metadata with the IDP, and your site's protected. You don't have to install a whole lot of infrastructure to get it to work. Okay, shifting gears big time. OpenID. So this is a somewhat older specification. This is an example of a decentralized. So with OpenID, you basically own an URL. So your login is actually a URL, and you say, you prove that you own this thing. And when you prove that, that gives you credentials to log into sites. So this was created for like LiveJournal back in like '99 or something like that. It's still used in some places. So the Fedora account system uses OpenID. So if you have a Fedora account, you're using this. I'm pretty sure the Ubuntu Launchpad still uses this. And again, you still need to, as a provider, you need to trust that identity source is actually doing the right thing. So you can also run your own OpenID server if you don't want to trust somebody else. And there's software to do that. So this is what identity looks like. It's just, a couple of links. And I'll show you in a second how this works. But so here's my Fedora project ID. And I'm going to break the cardinal rule of talks and actually use the internet. And we'll see if it works or not. I'll actually do a login. So same kind of thing. Let's show how OpenID works. Again, you start with a login request to a relying party. So it's going to do discovery on the URL. So there's a pretty complicated, actually has its own sort of RFC on how to decode what these URLs look like, because you can delegate things and you can redirect and a whole lot of complicated stuff. But basically it's finding out where the server is that you're proving is yours. An association is done with that server, and so this is like an exchange of keys, because again, this stuff is signed. It's HMAC, I believe, in this case. Redirect the user to authenticate. It's almost always username and password. They do authenticate. And then there's a validation that goes on between the OpenID provider and the relying party to make sure that, this is like making sure the checksum is right, that no one touched it in between. And then that's it. Tokens issued, you go on your merry way. So let me show you what this looks like. I'm using Flask. This is just a little Python example of OpenID. So it helps if I start the process. This is going to look terrible on the screen, just this command line stuff. So ignore the man behind the curtain. Okay, this is going to look a lot like the SAML. So I put my ID in. This is going to be a little slow because the Wi-Fi here is not great. Oh, it's not bad. So this is the Fedora authorization server. So now one of the things about, SAML has consent too. The IDP I was using had it turned off. But so you can actually consent to the information you're sending. Ubuntu is really quite cool because it's got checkboxes near all the data. So you can decide you don't want to send the email or your full name or whatever it is they're asking for. And you can also remember the approval. It's kind of like single sign-on, you sort of fire and forget. It creates a cookie. And so as long as the cookie exists, you're able to do your work. So I'm just going to allow this. This will be a temporary thing. And there I am. So here's my name and my email address that I got from Fedora. So again, pretty straightforward. Yeah. So OpenID itself is, that'd be nice. It's generic. So it's pretty free-flowing, and as specs go, it's not very tight. But one of the cool things about it is it provides extensions. So a lot of extensions have been written, a lot of them by Canonical. So the simple registration extension is similar to what the Salesforce case was. It's just, basic identity about you, email address, telephone number, street address, that kind of stuff. Things you would typically ask for in a registration page when you're creating an account. There's a more generic one called attribute exchange where you can define what attributes you want. So this is kind of special case stuff. And Teams is all about groups. So I'm pretty sure the last two are Canonical. So you can get group information. So when you log in and authenticate, what am I allowed to do? Fedora's got a couple on top of this. One is CLA for that you've signed agreements, and what agreements have you signed. So use cases. So this is pretty usually decentralized. It doesn't have to be, though. Like Fedora and Canonical, they only allow their ID provider to authenticate. So if I went there with another OpenID login, it wouldn't be accepted. So you can do the centralized case with OpenID, but it's usually decentralized. It's usually use your Facebook account or your Google account or whatever, and you log into whatever server. So this also provides for single sign-on in some cases. And the idea of this is user single ID or single identity on multiple blogs and forums and et cetera. This is the whole use your Facebook account for everything case. So here are some OpenID providers if you wanted to implement one yourself. So FedOAuth is the old system that Fedora used. They're using Epsilon now. WordPress has got one. There's a bunch. I couldn't find as many as with SAML, but if you try and search on OpenID, you usually get OpenID Connect because that's sort of replacing OpenID. Relying parties is a similar mixed bag. There's bindings everywhere for OpenID. And there's also, again, an Apache module that makes this pretty straightforward. And I just blazed right through that. How am I doing on time? Woo! So, did I go too fast? I can run through it again.
Hello, do you have any comments for using command line tools to access things that have to do with SAML? So one common problem we have is, someone has a large file that they made available via HTTP, but the site happens to be, behind a SAML thing, and it gets kind of complicated, if not impossible, to download it with something like curl.
Right. Again, so these are mostly web-based things, but so SAML, I think Shibboleth actually created this extension. It's called ECP, and it's made for command line. So like OpenStack is in the process of adding ECP to their tools, so you can do federation. Keystone, I don't want to turn this into an OpenStack talk, but Keystone is trying to get away from being an identity provider to being the authentication system. So they're trying to outsource all their identity elsewhere, and SAML is one way to sort of shove it all aside. And so you would use SAML everywhere, and ECP is a big part of that.
One big gotcha that I think you may have glossed over a little bit too much.
Oh.
Sorry. The single logout stuff is extremely new. It's like in the last 3 or 4 years, I think they finally standardized on the spec. Most SPs that I've worked with don't support it at all.
Really?
Yeah.
Okay, because the ones I looked at.
Which specifically, please?
Okay, so Simple SAML PHP, Shibboleth, Keycloak. No, it did. Well,
Shibboleth supports it now.
Okay.
There's tons of deployments out there that don't.
Sure, yeah. I
That's, I mean,
tested,
that's the gotcha is
Yeah.
SAML, and this was actually a huge problem that I have with SAML, is especially in contrast to OAuth, which I was actually kind of surprised you didn't go into that. OAuth has sort of supplanted OpenID as the less complicated single sign-on-y thing. The SAML spec is entirely too large. I can't count the number of times I've seen problems with basic validation of the signatures, because there's like 3 or 4 different ways you can canonicalize the XML document to generate the signature, and pretty much every SP has to be able to deal with those. Yeah.
yeah.
But you need to be very careful and do a lot of interop testing between any particular IDP that you want to use with any particular SP.
That's true, yeah, right. Yeah, specs only get you so far, right? Because it all depends on who implements it. So that's why I found that when I only tested the latest shibboleth, but it worked pretty much anywhere. And I think people use them to test against when they do interop testing. But you know, some people don't like it because it's Java, and some people feel that Java is rather heavyweight. You know, I don't want to get into a big flame war about it. I don't care one way or the other, but I know that you mentioned Java to some people, and they sort of recoil in terror. So.
Any other questions?
One in the back.
Back there.
Oh, whoops. Okay. I had more of a, I guess maybe you could comment on the implementation. You said that people are just slowly starting to implement it. Do you have any sense of like what's going on there, or like what are some of the sticking points, or is Red Hat going to be asking all of the vendors it works with to implement it, or?
So Red Hat, I can speak for, well, I can't speak for Red Hat. I can talk about my experience as a user, because I didn't do the implementation. But within Red Hat, we use SAML in most places. And we're slowly converting over those things that don't support SAML to support SAML. So Red Hat also has Kerberos, which is also single sign-on. But Kerberos can be kind of scary, and Kerberos doesn't work so great across the WAN, because then you have to open up your KDC to the internet, and no one really wants to do that. So SAML is a way around that. So you authenticate using Kerberos to your SAML IDP, and then you use those credentials to get out.
Can you talk about the difference between what you're talking about and OAuth and the relationship? Because people get confused by that a lot, and I haven't heard a good explanation unless you actually get in and start coding.
Yeah, honestly, I don't know a whole lot about OAuth. OpenID, I put it in here just so I could have it decentralized, but I'm more of a SAML person. I know at this as a 10,000-foot level, I know how it works, but underneath, and OAuth is being replaced by OAuth 2, for good or bad. I know a lot of OAuth 2 is a spec by committee, and I guess it says, I think somebody told me there's 11 places in it that says this is not covered by the specification, so it's really loose. Oh, he's got another comment. But
On OAuth 2, the right way is not to view it as OAuth 2 as a protocol. The right way to view OAuth 2 is as a toolkit with which you can design an authentication protocol. It's just too big.
oh, there you go.
Something else that I've heard, and I wonder where it relates to all this, that with mobile devices, a lot of apps are getting authentication, and there seem to be two main ways. One is to delegate to the operating system, and the operating system has some sort of, it's usually called OAuth, but it probably that's probably as inexact a term as ever. To delegate to the operating system to log you into Google or Facebook or whatever, and then you go back to the app. And then sometimes apps pop up whatever the browser's web view is and send you. And of course, with that, you can't know exactly what you're getting, right? For all you know, you're getting a Trojan horse page. Do the things you talked about today have any relationship to that?
So SAML doesn't have a great story when it comes to mobile devices because it wants to do post a lot, and most mobile devices want to do get for whatever reason. There are ways around it, but from what I've read, they're kind of hokey and not really great. OAuth, OpenID, and OAuth 2, OpenID Connect-based protocols work better for mobile, at least today. I don't know if the SAML team is working on mobile or not, if they care.
All right, anybody else? All right, let's thanks Rob for the great presentation.
Thank you.